Good morning, Professor Yao. I hope all is well with you today. For my optional project for the final, I have decided to talk about the magnetic levitation trains. I will read off the slides. It says, magnetic levitation trains are also known as the maglev trains, and they are a type of train transportation system that functions by a process that consists of two different sets of magnets. And the purpose of one set of the magnet is to allow the train to levitate, and this occurs through the process of repulsion. And the other set is to cause motion to the elevated train so that it can propel forward in a certain direction. Here is a picture of one of the types of trains. I thought it was interesting how the shape was. In order to talk about the analysis and the detailed explanation on the explanation behind magnetic trains, I thought I would mention how there exist different types of maglev trains. There's the ones that I have researched are the electrodynamic suspension involving repulsion and the electromagnetic suspension involving attraction. The one that I will discuss for today's project is the electrodynamic suspension train this one involves superconductivity in order to reach the levitation. Superconductivity was a topic that that you taught us in class, so I thought that was a good type of train to talk about for this project. From what I've learned in class and from further research, superconductivity is a phenomenon that occurs only in certain types of metal materials at extremely low temperatures. These are specific temperatures. When a metallic material is in its superconductive state, it has a resistance of 0. This is explained by the Meissner effect. This effect states that a superconductive material will expel the magnetic field as it transitions to its superconductive state. Here is an image explaining that process. And I believe it is important to mention that the extremely low temperature that the superconductive material must reach is very specific and different for different types of material. Here is a little bit of an explanation of how these types of trains work. It says the way these superconductive trains work is by floating or levitating over the train tracks using the basic principles of magnets. In this scenario, no friction exists since no contact is occurring. With no friction means that these trains can reach very high speeds. Magnetic field is created by the coils, with an electric current passing through the coils located in the tracks that the train ride on. There exist two different sets of coils for each different purpose of levitation and propulsion. This image here can kind of describe that. It shows the propulsion coil being these here, and the levitation and guidance coil being these here. I am sure there is a reasoning behind their different types of shapes, but I did not go into further research as to why they are shaped differently. But I thought it was interesting how it was two different types of coils working in the same area, as seen here, for different purposes. With these two combined, the train is able to propel forward as it levitates. What I found interesting was that these superconductive trains have different models being developed around the world. And what caught my attention was the Japanese model. The reason why I like the Japanese model is because this type of superconductivity is the one that involves the supercooled electromagnets, which was similar to the demo that you showed us in class. The Japanese explained that this is advantageous for them since this type of electromagnetic can conduct electricity even after there is no power supply due to the superconductive properties of the metal used. I thought this was interesting since the Japanese explained that it's useful for safety purposes if the power supply is cut off for any reason. it's better in contrast to the standard electromagnetic system trains, because if the power does shut off with those types of trains, the train is no longer in functioning motion. Here I have involved an image showing different types of levitation trains. Here's the electrodynamic, the electromagnetic, and the induct track. And then for my conclusion, I thought it would be interesting to list the advantages of using this type of train, in contrast to the common model of trains that is mostly used today. Because there seems to be no contact between the train itself and the tracks, this can mean that the tracks will not be exposed to damage of being worn down by the contact between the train and the track. And this can lower the cost of maintaining. And another thing that I would like to mention is how I thought that it was interesting to see a topic that we learned in class being applied to real life situations, because I found that it was very rewarding to be able to understand the concept behind something so behind something so complex. I would like to thank you for this semester, and I hope you have a Merry Christmas. Thank you.